All right, we're going to move on, folks. Next lab. A couple other things to look at here. So we're going to look at real quickly the documentation on how to write a file. Some kind of interesting little things that you can use. So there's a few different switches that you can add to the, these file manipulation things. There is the A switch, which actually adds stuff to the end of the file. So if you're working with a regular text file, you want to append some text on there, pretty easy to do. Could think of the power that could be, for example, if you were writing a program, for example, that was creating a log file for an admin, you would just have it append to a text file that the users don't even need to worry about, right? And then if something goes wrong with the program, you can look at that file and, etc. How about the W switch, where we can open the file and then write directly back to it? That's another one. It's a variant of the append, because this one can alter the whole file, while this one just adds to the end of the file as it exists already. So real basic examples. They have a couple of examples here where they've, they're worthy of taking a look at here. So let's just do that really quick. So here they're opening up their demo file. They're having the append, then they're issuing a write command, right? And then they close it, and then they open it in a read format, and then output it to the screen. And what happened with this? Why is this? Is it coming back into the file or not? Well, we really don't know that, I guess. Let's try this in our own type of code, right? Let's see if we can just demonstrate this really quick. I'm just going to create a really quick little file, and I think this will be kind of fun to do. And we'll have to create this file. I'm just going to put this actually in the same folder as the lab files. So just bear with me here.
Can you copy that into chat so we can all throw it in there?
Yeah, give me just a sec, please. I'm just going to create a little test file. If you guys want to try this. Now, I'm going to be changing the name of the text file, and probably easier to just maybe take one of these. Actually, let's just create our own. All right. So I'm going to create one right in the root folder with where I'm working. And I'm going to call it exactly what they have, so I don't have to rename it. Demo file 2. Very silly, but I have some text in it now, right? So you guys can see my silly text. What's in there? And let's
Would you call it? I'm sorry, demo file 2. Oh, I see it. .text.
And so notice what the append command did. So it opened the file. You guys know I didn't add this text to it. I used the write command because the append thing was added to it. If I wanted to put this on a different line, I could \n first. So if I was to run that again, right? Oh, it still put it in the same spot. So it didn't include that. And I think I know why. But that's an example of using the append command. Now, I think what would be fun is to also bring over their other command here, which is the write. So we're just demoing here, basically.
Did you put that in the folder?
You can grab those from the same spot I'm grabbing it from, by the way. You should have access to the link. Now I'm going to remove this example. All right, now watch what happens on this one. Now, it's kind of silly though, because I don't have this file, so let's switch it. Now, we know what's in demo file 2, right? It's a bunch of ASDFs. And when I run this, what I'm showing you is by switching it to write and then running a write command on a file that already has stuff in it, guess what that does? Yeah,
Overwrites it.
yeah, it overwrites it and it destroys the content. Now, interestingly, if you wanted to preserve the content, you could do that by reading it in and storing it in a variable temporarily. And then you could alter it and write it back, or write it back as is, or, whatever the case may be, you would be able to do it, right? But it shows you the difference though. When you trigger that one, it is destructive. So careful with it is basically kind of the caution here. All right. There's also the X switch, so if you use this, that just simply creates a file called that. And once it's created, then you can start writing to it, right? So that's a possibility too. Okay. Write would also do the same action. I guess I'm going to be real frank, I probably use that approach more often, personally. All right. There's also the date time object. I'm going to give you code on this, and hopefully we didn't have the same fiasco we had last time we did it. We're just going to be, using basically this module again. I have the code pre-written. I'll drop it in the chat for you, but we're going to be pulling information, maybe not quite in that format, but similar. There is also, like, if you really want to kind of get deep into this and start working with, like, file dialog boxes and stuff, there are ways to do that where you can interface with the operating system. You do have to import a module called OS, and basically, as it sounds, it's designed to interface with whatever operating system and trigger its default mechanisms for routine tasks, right? Opening a file, saving a file, those types of things. And those are just calls to the OS. This is information about how to use some of those things. If you want to kind of dig in, the info is out there. But let's tackle these tasks. All right, so it says in the project folder, create a lab 3 files, and then create a folder in that folder called receipts. So a folder in a folder. All right, so let's do that.
In
I'm gonna
module 6, you're creating a new folder?
Excuse me?
In module 6, you're creating a new folder or a new file?
Just watch what I do. I'm going to be creating folders and files, but folders first. Okay. All right. So as we were saying, we're going to create a lab 3's files. So lab. Capital L, capital F. Inside there, we're going to create another new folder. Receipts. Why? Because that's what we were told to do. And it's really about kind of like working with the files and folders is what it's about. All right, and then the requirement here says, continue asking the user for an item and cost as long as they choose to repeat the process. For each iteration, create a new file with the following naming convention, order N, where N is the order number. Okay, it sounds like we have to increment some numbers. At the start of the program, find the current order number based on the file names in the folder. So kind of a lot going on there. Let's start with some basics here first. We do need to create the program file, so I'm just going to create that right now. Looks like it's not going where I want it to. Let's put it there. And we're going to call this module 6 lab 3.5. We are going to be using both of these libraries here as we're working. Type that in. We're going to be keeping track of our order numbers. Oops. So what we're going to do is we're going to create a variable called order number and preset it to 1. So the first order will be order number 1. And then we'll just start counting up from there. So now I'm going to write a simple loop. Trigger it to true to run. We use this command here. So we're say if the operating system path exists. So we're calling in that operating system library. So we're checking to see if the file location for receipts is present or not, right? Because we don't want to write a file to it if it's not there. So inside here, let's do this with an F string. We're going to feed in the folder that we're looking for. And then we're going to check to see if the file that we want, right? And I'm going to feed in the number here. So that's going to be the order number thing I created above. And then we append txt to it. So in other words, we're going to be creating receipts. The receipts are going to be numbered. And then I'm going to be able to look at those and cycle through them. And you know what, if there is that present, then I will increment that order number 1. So in other words, we're checking to see what files are in there. And it's like, oh, there's 1, 2, 3. Check all of them. And then when it stops, it will add an order number. So where I'm going with that. And then otherwise we will break up. So once it's done that, out we go. Another loop, also force to true. And this is where we're going to basically build our receipts. This is what's going to go inside each one of the files that we create. So let's come up with some stuff to put on there. And I think that we're going to need an item. We'll allow it to be input. Let's do a tab stop at the beginning. So item space. So we're prompting for an item. Prompt for cost. Also put a tab stop at the beginning. Oops. Yeah, we probably should convert that to a number and do a bunch of stuff to it, but that's not our point here today. Here's where we're going to use the date time thing. Here's the, I'll just give you the whole line in the chat. So what is this going to do? It just timestamps whatever now is. Takes date, time, down to the second, et cetera, et cetera. Not dissimilar from like how a real point of sale system works, right? Do the same thing. All right. Now we're going to start processing the information inside the file, and we'll do this kind of in an incremental fashion. Just moving my screens around a little bit here. So let's create a variable called receipt. This is where we're going to manipulate all the stuff. We're going to open up the file, string it. All right, and what are we going to say? We're going to say receipt order, and the same like file handling format we were using above, same variable, and same .txt at the end. But this time we are writing it, or we want to be able to write it, and I don't type the whole word, just type W. So we're opening it in write mode. And then we're essentially replacing whatever contents are there, or if it doesn't exist, what's going to happen, it's going to be created. So we'll issue the write command, parentheses, and then inside there, F string format again. We can do something like, or we have a space in there, order, and then we can put in the order number, space, whatever ASCII art you want to put in there. Let's throw in a blank line, or carriage return, actually. So we're writing that to the file, including the carriage return at the end. It takes us to the next line. So we're just going to keep basically repeating this process, right? So I'm going to add this. I'm dumping it all on the screen at once. But you can see I'm going to tab in for item, tab in for cost, put a $sign in front of the cost, include the item number in there, and then I'll have a little timestamp at the bottom. It says purchased. Timestamp goes in. That's going to be grabbed from up here. And then here's an important part of this. Whenever you're working with a file that you're changing the contents, and this is one that can cause problems if you're not careful. You want to take that file and you want to close it. And there's a command for it. And basically what it says to the operating system is, hey, I'm all done. Somebody else can open and change this file or look at it now, right? If you fail to do that, does it break your file? No, it'll automatically close and the program's done in principle, right? But what if the program runs into a problem, it gets stuck in a loop or something, right? Then that never happens and that can be problematic. So writing it into your code is always the right thing to do. Right? Now, every time we do this, we are going to increment our order number by 1. So plus equals 1. And, you know, by the way, if it's helpful, you want to like split your code up like this, you know, whatever makes you feel comfortable. And then I would say, all right, do we want to give them the chance to add another item? And so let's prompt that, but inside of an if statement, and we'll say add another item, question mark, and then maybe a yes, no space, something like that. And we should, oh, what are we checking for? So as long as that does not equal, so that's exclamation equal so if that happens, then what do we want? We want out of this loop, just break up. So there's the second loop. You guys have a second looking at it if you want to try to type it in or pause the video and review. Will this do all the stuff that we needed to do? Let's check it out. All right, so let's look at the directive. Continue asking the user for item and cost as long as they choose to repeat the process. For each iteration, create a new file with the following naming convention, right? At the start of the program, find the current order number based on the file names in the folder. All right. So let's see if it does all of those tasks. That's the run. All right, so let's enter an item. All right, ran into an issue here. Let's figure out what the issue is. All right, so it's pointing me to, oh, file not found. All right, so that's indicating that it's not finding the first file, right? Why is it not finding the first file? Well, because we haven't created it yet. Let's take a look at the code here. Figure out why that. Let's also take a look. Folder is empty, right? Let's try running that again, but let's figure out where it might be hanging up. Let's block this out here for a second. All right, let's try creating this in advance and see if it traverses. So I'm going to go into the folder here, folks, and I'm going to create I think that's the correct naming convention. Let's see if it runs right now. So now we're looking for typos and folder names. Did I spell receipts correctly? Oh, aha. It's not Naha. Trying to see if I have errors in my sample code. Let's check our folder structure really quick. So I'm trying to figure out like where the error is here. So I'm going back up to this level. And then from there, we would go to our lab 3 files. So I'm just looking at, paths, right? All right, so that in essence would be the problem then, because if I'm telling it to go into the receipts folder, but I'm doing it from one folder level too high, you guys catching that? And so here, I need to precede it with lab 3. So it was kind of an aha, but not quite so instantaneous as I would have thought. All right, so there we go. let's try this code, see if it runs. So now the the proof is in the pudding. So I'm going to go in and look at that folder, and there's the file, and there's the text. Okay, so it's making it in. So now that code is working. Now, this first piece, right? And you know, I kind of feel like I need to circle back to that because it's probably not there. So for each iteration, create a new file with the following thing. We did that. All right. At the start of the program, find the current order number based on the file names in the folder. All right. So trying to figure out how we add that step to it. So, all right. So this will read through and get the order number, and that'll increment the order number so that when this hits, it will know which order number to start on. So the next time I run this, so this is the conceptual piece here. Now it will create order number 2 automatically, but only if this stuff is uncommented, right? With it commented out, it would basically do what it was doing. It would always create order number 1. Because why? Because that's where we're starting. We're still setting it, but now it's going to read in. And if there's a higher than order number 1, and it's going to read in the order number, it's going to add 1 to it if the file exists. So you guys see how that works? All right, let's save this. Let's run it. Let's let it do all the prompting and stuff. All right, and this time we'll say water, $1.99. And let's, okay, fine. Let's add another item this time. I don't know, breadsticks. Those are $4.75. Now we'll say no. Now let's go take a look at the file. And yeah, we could write code here to read it back, but we can also just go to the folder and look. And notice we do have order number 2. Well, this is kind of an interesting thought here because we're having discrete runs of the program. The program doesn't continue to run. It runs, it stops. But now it's intelligent enough to look into the folder, see the name of the order number, right? And go, oh, your next one is 3. Pretty cool, right? Pretty simple, but pretty cool. All right. That is the entirety of the lab. Anybody having issues? Right. Moving on to lab number 4. These are our requirements here. So it says in your project folder, create a folder called lab 4 files. And then everything that we're going to work on is going to point to that folder. Okay, so that's going to be pretty important relative to wherever our code file is located. So that path is important, obviously. And let's go ahead and create a new lab file. So I've been putting all of mine in the module 6 labs on the top level. I'm going to continue that practice. I'm going to add one in the same spot called module, oops, turn that caps lock off. Module 6 lab 4.py. It's on the same level with all the others. I'm also going to create a new folder called lab 4 files, capital L, capital F. And then that's where we're going to put whatever stuff we're going to put, right? That's where we're going to create it. That's where we're going to store it. So file management first is always a good approach. I have the lab file open. And let's see here, we need to get back to our directions. All right, so now that we have that, now we're going to create a class for a person object with the following properties and methods. So we'll do a little bit of repeat to not lose our other skills. We're going to have the init method, a string method, and an output to file methods. It's going to be built into the object. Kind of interesting. All right, so we'll do that first, and then we'll work on that list. So let's do that first. So let's get over to our code. I am going to be importing the following libraries. So, hey, we're going to need that helper file again. So I'm going to call on that. So I'm going to go back over to my module 5 labs, copy that helper file, come back to the module 6 labs and paste it here. So it's in the same folder. So that import here will help. So we're going to use that get in function so that to help with our menus. We've used it before, so you know what we're talking about. We're importing OS so we can interface with the operating system and the file handling. And here comes our class. So we're going to create a person, capital P. And let's create the init function in which we will define all of the major data properties. So we'll have the self-referring. We're going to feed in first name, last name, and age. And then we're going to apply those to self-referring variables here. So we'll just follow the same naming convention. Firing on all cylinders there. Want the auto type to do it, and sometimes you just keep fumbling so much it doesn't. That's more like it. And then we'll do age. Like so. Come back out one indent here. We'll create the string function. Remember, double underlines on both the init and the string function, otherwise they will not work. We did have a couple people still doing single ones, and just remember not to do that. We're just going to do a return statement here. Well, it'll be an F string format, and we'll just say self dot do last name first on the output, and then self dot first name, and do a colon, a space, and self dot h. That'll be our output. There's our init. There's our string. And then we were also, I think, told methods output to a file. Now, we haven't gotten to that point yet, so let's not worry about that piece quite yet. But we'll, in principle, create output to file. What do you put in here if you don't want it to execute? That means we can come back and work on it later, but the structure is in place. The example I'm working from didn't actually build that method, by the way, into the object, but we're going to see if we can pull it off. Next directive is pre-populate a list of at least 8 people. This one, let's do this in a copy-paste fashion. So in the chat to save you typing, right, this is just data, basically, is this code. So we have a list of person objects. So we're calling it people. Sort of makes sense because an individual is a person and a collection of them is people. That's maybe a good trivia question. What is the plural of, or the singular of people? Hopefully you're not typing that manually. Grab it from the chat. Copy paste. All right. Next task. Create a menu and functions as described. So we have 1, 2, 3, 4. So these are all going to be functions, correct? All right. So let's kind of build that. That sounds like a while loop, like we've been doing all along. So back to our code. We're going to create a little blank space here. This is going to go way at the bottom. While loop forced to run. Right. We'll do a little bit of output here. of putting a really basic menu. Paste. List files, create a file, read a file, delete, etc. You want to make it look prettier? Go for it. Right. Then we're gonna do a prompt, which really exists out in our helper file, right? So this is a preset function in there that gets an integer based on our selection. The original get int, by the way, if you remember, was set up to do 1 through 4, and anything else would pop you out. So that works for this. That's why we're using that. And for those maybe watching the video cold, I suppose we can show them the function. Well, let's just type that in there too. All right. All right, now let's build an if statement here, a series of else ifs to handle the menu choices. All right, I'm going to give you guys a moment to type this in. You're like, please copy paste. Right, but what we're going to end up doing is we're going to build all of these functions one by one. I'll just give you a moment. It shouldn't take too long. I'm going to assume you guys are getting to that point where you're about done. So I'm going to go ahead now and I'm going to start building definitions for each one of these functions one at a time. So I'm just going to copy the name that we have here. I'll scroll up, give them a little def, paste in the name. For right now, I'm going to type pass on each one. I'm just creating them. That's it. Then we'll feed in the code later. Structure in place. All right. Let's go back to our instructions just for a moment. And I know you guys should be able to do that without me guiding every step of it. Let's look at these commands and see what makes sense here. It says, first one says this should list all the files in labs 4. So that just going to read into the directory and then give us back a listing of the files. All right. That sounds like an easy one to create. And then test. So let's do that one first. So that's going to be list files. So this is where we're going to add our code. And I'm going to need to give you the code on this one, right? So if we want to set up a variable to read in this information, we'll call it files. Why? Because we're reading in from the operating system. So from the OS, there's a list directory function. And since we're one folder level above, we're going to look into lab for files and a forward slash that knows to go into the folder. All right. Now, to test this, we would write a little loop, right? So we would say for each file name in the listing of files, we will do the following. We will print F string, and we'll just do a tab stop and then the file name. Okay. And actually, we got to make that. Well, we don't have that variable created yet, but let's create one called file name, which we need to. I'm just trying to think here. No, we would not need to feed that in, right? Because we're creating it here. All right. So one problem with this to test it, the problem is we need at least one file in there to see if it's creating anything, right? So let's go to that folder physically. And I suppose we can do it from the side panel, but I'm kind of liking going this way sometimes. All right, so we're going into module 6 labs. We're going into the lab 4 files, and we're just going to create a new text document, and I'm just going to call it something silly like ASDF. All right, so it's created. Now I should be able to come back here, make sure this is saved. And then I'll run the program and I'll choose the first option, right? The list files. So let's give that a shot. Here's the run. All right, we'll type in, look in the console, type 1. All right, and there it is listed. So it's working. Yay. Right. So that's good. Right. I can leave that file there. You can remove it if you wish, up to you. I am going to type 5 now to get out of the program. You should do that too. Close the console. All right, so that's 1 down and a few to go. The next one would be, well, let's think of which one might be the easiest here. Let's read the directions. Create file by age. This should create a file with a name specified by the user and contain all people within an age range specified by the user. Okay, sounds like a combination of tasks. I'm going to just copy that because, real frankly, I might forget it. I'm just going to put it in here as a comment. Oops, paste. And tells me that word wrap should be turned on.
Could you go all the way back up to the top and let me take screenshots from the top?
Okay. All right, so let's get rid of the past statement here, and let's think about this process that we have to do. So the first thing we want to do is we want to ask for the file name. So watch how I'm going to put this together. I'm going to create a variable for it, and then I'm going to, because wherever we go to, we have to append lab 4 files / right? But then I'm going to prompt the user to input the actual file name so they can choose the name of the file. And then we will append to that .txt. Don't forget the dot. Right, that's the first part. Then we'll take that file and we will open the file that they just named. So we'll call file name, and we'll open it in write mode, which, guess what, creates it. It actually creates the file. Now we're going to set up a couple of variables, and we're going to ask the person to enter an integer value for a minimum age and a maximum age. So let's just do that. So let's create a variable called minimum age. We're going to run the getInt function, and we're going to prompt for enter a minimum age. And as you can imagine, max age should be very similar, so I may as well copy paste and do some creative tweaking like so. Then we're going to write this back. So we're going to do file dot write in parentheses in a f-string format, if I can get my cursor back to the right spot. I don't know, you can make it pretty if you wish, but you say something like people from the ages of, and then you can add minimum age, oops, to max age, and then maybe a little more decor there, something like that. So we're writing this to the file. Right. Right. Then we're not done writing to the file. We're going to keep writing to the file. Now we're going to set up a loop to do the other part, which is for each, okay, so if you want to do this, maybe for each person in people, so see that, so where that singular and plural comes back. But normally, like if I was doing that, I would think that, but then I would probably just get rid of all that and just use the letter P, right? Because I get it, and also there's kind of a really secondary kind of not trick, but logic to it. It really truncates how much you have to type. So whenever you're expecting to retype a thing over and over again, well, this kind of saves you the hassle of that if you're clever about it, right? A single letter is a very clever way to do it if you know what you're talking about. So we're going to say as long as the age of the person in that list is greater than or equal to the minimum age, and that person's age is less than or equal to the max age, then we're going to go ahead and write that back to the file. So only if they fall in the age range will we read them back in. Let's see what I'm trying to achieve here. So then we're going to do a write, and then f-string it, and then say backslash then new line, and then whatever P is, which is that person. So it's only going to list the person. Really, really simple. There's the code. So that's create file. I'll let you sit on that for a second. I'm going to scroll it up to the top of the screen, and then I'm going to get ready to do a run here in about a minute. Okay. I'm going to go ahead and do a save. And here comes the run. So we're going to try that second option now. So we're going to type 2 to create a file. Oh, that's kind of interesting. Not what I expected. So I must have an error in my code, right? Ah, yeah, sure enough. Okay, so I'm gonna terminate the terminal, and let me show you where my error is because I kind of blew it here. Because I want them to input the file name, but I want that to end here, and then I want to append .txt to it, not include that in the prompt. You guys see that? So I'll give you a second. So I tweak that. Saving. That'll still be in view. I'm going to go ahead and run it again now. All right, so create a file, enter a file name, one of my favorites, whatever. Enter a minimum age, how about 15, maximum age 45. And then it broke. All right, but let's see why. All right, so let's syntax here. It doesn't like my syntax. Line 66, where I'm calling create file. And then it drops into the module in line 46 and gets to this line. It does not like that syntax. So let's go take a look at that syntax. Shouldn't be too far from where we are here.
I think that's the string function, isn't it?
Yeah, it could be. This is broken here somewhere. Oh, yeah, sure enough. Good catch. Right, you see what happened there? Yep. Yeah, that was a really good catch. All right, so there's the revised string function. So I was missing that bracket. It was out here. All right, let's try that again. All right, saving. Running again. Let's get it all in view. 2 to create a file. Whatever. Minimum age. We'll use the same numbers, whatever those were. Supposedly it did it. Now I can, instead of going to my file system, right, hypothetically, list the files. It's there. Now I could also, right, so you can imagine where you could ramp this up to. I could write another menu option that would say, which file do you want to output? And then we could look at the file too. But instead, for now, we're just going to come here, open it up. And then are these people between the ages of 15 and 45? They are. Pretty cool. Simplistic, but kind of powerful at the same time. Right. All right. So that's proof that that part works. All right. Let's move on to the next piece. So we got some more stuff to build in here. So create a file by age is working. And then we need to be able to read a file. So get a file name from the user and output the contents. All right, so let's do that. So it's the terminal here. So that's going to be the read file. So that's going to come here. So first thing we're going to do is, why don't we list the files since we have that capability, right? It's just a function, just call it. And then we're going to just prompt here for a file name. Ask. So we have to append this to our path. It's going to be part of it, just kind of like what we did above and I screwed up the syntax. Except this time the syntax will be perfect. So we'll ask them to input and say, enter file. And then they will type it in. Now, does this assume they're going to type txt? It does. Right, so that's an assumption. Now we'll run an if statement here. And here's what we're going to ask. We're going to ask if that is present. So we're going to say, if the operating system path exists, that returns a Boolean based upon a particular file name, which we are providing, or user provided. So if it's there, we're going to take the file and we are going to open it. Which file? The file name that they fed it. Since you found it, now you can open it. Then we'll print out its contents. This would have been handy earlier, so maybe we should have started with this one. And then, okay, well, we're done with it, right? Close it. Like, what happens if it does not exist? Well, maybe at least a polite message. And you could say whatever. You could make suggestions for fixing it, even if you wish. Right. So I'm going to click here for a second. I'm going to save. moving that to the top so you guys can still see it. And then here comes the run. Oh, and I think I never ended the last run. Okay, now let's run it again. So let's do a read file. Shows me the list. So I'm going to enter whatever.txt. And it says cannot find that file. All right. But it's right there. So where is our flaw? Should we try to read again? And maybe we just say whatever. Well, that doesn't work either, right?
You're missing the / on your lab4 files.
Ah, okay. Well, thank you, sir. Let's type 5 down here to exit. Good catch. Who said that? Eric?
Yep, that was
Yep, very good catch. Thank you. Oops. All right. Let's relaunch. Save. Launch. Here we go. Read file. Whatever.txt. Hey, all right. So now it's reading it, right? So that's good. All right. I think this is a good spot to take another break. I'm going to pause this time. Let's do like a 5-minute break. And then we'll come back and we'll finish the last part of this. And then we'll kind of queue up for the assignment. All right. See you guys in 5. All right. We're going to now pick up and get this last function completed, which is to delete a file. All right. So I think probably helpful to see what you might want to delete. So we'll list the files to begin with. And then we'll grab a file name and we'll prompt, kind of like we did before. So we'll do lab4 files / we don't want to forget that. That messed us up last time. And then input, enter a file, just like we did before. So we're just going to capture that. Then we're going to check to see, is it there? So if the path exists of what? Well, the file. Spell it right though. No wonder it's not finding it. And then we'll use this command, which should kind of seem similar to like a list, right? Because it's sort of like that, right? But you just do remove and it deletes the file. Oops. If it does not, then a simple little error message would suffice. Something like find that. Pretty simple. Go ahead, save that. Moving it to the top and go ahead and do a run. All right, so let's type 3, read a file. Let's read asdf.txt. How do we know it worked? Well, we'd have to look, right? So it did not work, correct? Let's go check. Refreshing. All right, so now we got to check our pathways here again. I think we're okay. Let's check the code. Check that I'm doing right code here. import. Make sure that's there as well. Let's check our code here one more time. I'm gonna run this one more time. I'm listing the files first. Let's go ahead and create another. That time it worked. I'm not really sure. I'm just guessing that maybe like my console was like stuck and there was stuff stuck in memory there. So I kind of terminated all the console processes. I hit the little trash can, closed it, ran it again, and then it seemed to work. So now it is functioning. Let's try deleting another to make sure. So here's another. Listing the files. Okay, that seems to be working. Let's create one so at least we have. Okay, it seems to be working. All right. So I'm going to go ahead and exit on this and we'll call that lab done. I'm going to terminate this video here and then I'll field questions.